We're starting chapter 4 today. Now, I said that we're going to do 2 days of chapter 4 and chapter 2. Actually, we're going to do this in one. Because what we're covering in chapter 4 for this year is actually not that bad, especially for 4.1. 4.1 is radians and degrees. Now, you know, you've dealt with degrees before, because the circle is what? How many degrees in a circle? There's 360 degrees in a circle. Well, that's what we've set a circle to be. We've set a circle to be 360 degrees. And that's really going back to the Greeks, if I remember correctly, set the circle as 360 degrees. And by this point, you've done, or at least read Plato and Socrates and Aristotle, some of their work, or at least one of their works. I mean, probably by the time you're done with college, you'll have read at least some of their work and talked about them. And if you've read anything in Greek, Origin, or kind of their philosophy and their train of thought was always about they wrote a ton about the perfect society, perfect utopia, what is perfect. They were obsessed with being the perfect, ideal situation. And what they thought was really the most perfect object that you could have, a circle. And they decided the perfect number for this perfect shape was 360. It's not. That's why we have pi. Pi is the approximation of I want to say the diameter over the radius, or no, not this radius. It's the circumference over the diameter, if I'm remembering correct, so I might be wrong, but it's this ratio of finding what the actual amount around a circle is. So it's not right. So it's not going to be exactly 360. But we have kept it as 360 because 360 works nicely for most everything that we cover. 360 degrees is actually a nice unit. And then we have pi to adjust for the actual difference when we're actually talking about the length. So we have these two units, radians and degrees, and we can switch between the two. That's why on your calculator, it has, I believe, up at the top right now, or especially on the TI-30XS, where it says RAD or DEG in the top. Pretty much right up there at the very top, it says DEG or RAD. Yes? This changes the value. So in there, type in sine of 45. Square root of 2 over 2, okay? Hit mode. And you see down there where it says degree or RAD and DEG? Scroll over to RAD and hit enter. And then do second quit. And now do sine of 45. Those are not the same, because it'll do the square root of 2 over 2. If they were the same, it would do the same thing. So radians and degrees are different, yes? So now one of the jokes I have on my wall will make sense. Your brain talking to you while you're sleeping. Hey, are you sleeping? Guess what? The calculator was on degrees. Or vice versa. Because as you can see there, it gives you if you were wanting it in degrees, plugging stuff in degrees, and it was in radians, it will give you the wrong answer. If you're wanting, or vice versa, if you're wanting to plug in radians, but it's set in degrees, it will give you the wrong answer. Does that make sense? So making sure it's in the correct units is going to be important. Angles. Well, as derived from the Greek language, the word trigonometry means measurement of triangles. Initially, trigonometry deals with the relationships among sides and angles of triangles. An angle is determined by the rotation of a ray half line about its endpoint. So we're just rotating and measuring this rotation. Now the starting side is what we'll call the initial side, and the end, or where it's going to, is the terminal. Now for us, our initial side is going to be the positive x-axis. That's what we're going to call the initial side, always. That's where we're going to start. The terminal side is wherever it's opening to. Okay? Initial terminal. Now, clockwise or counterclockwise is positive. Clockwise is negative. So if we talk about a rotation or an angle, if we're talking about it being positive, we're going clockwise. If we're talking about it negative, or sorry, positive is going to be counterclockwise, negative is clockwise. My best guess, and this is purely a guess, is I feel like this has more to do with Greeks and the Arabic region. I don't know what the exact civilization back then would be called, but those two are the leading ones. Actually, the Arabic region over in there was actually more advanced than the Greeks ever were, and the Romans. They actually had the concept of zero before the Greeks ever did, or the Romans. Romans had no concept of zero. That's why we use Roman numerals, because they did not have a base 10. They did not have a concept of zero. But the Arabics actually did. They were actually more advanced than the Greeks. So, and it's coming from that there when we talk about kind of navigation, when they're using stars and constellations, we always start at eye level and look up counterclockwise. That's my best guess at it. But for us, whenever we talk about a positive angle, we're going counterclockwise. If we go clockwise to it, it will be negative. Now, from here on out, we're going to use alpha, beta, and theta, these Greek letters to describe angles. So if you see these coming up, it's just talking about an angle, sine of alpha, sine of beta. We're just talking about these different angles. So instead of using x, y, and z, or those for an angle, we use alpha, beta, and theta. So they're just describing an angle. Now, what we also have is something called coterminal angles. Coterminal, let's go back. So if I talk about an angle here, I'm going to say this here. Go in this direction, it's 120 degrees. Yes? So we go 120 degrees. Now say I pass it up and I come back here. Well, where am I at? 360. I went back to where I started, yes? So I'm at 360 and then I go here. So I went 360 degrees and then an additional 120, yes? So this would be for 360 and 120 would be 480. Am I at the same spot? Well, yeah, it's still, I went all the way around and I'm back at 120, yes? This is a coterminal angle. This is the same angle, I just passed it up once and made it back around, yes? This coterminal angle is really what I'm doing is I'm taking that 120 degrees and adding 360 to it. And I get back to where I'm at, yes? I can do it as many times as I want. If I really wanted to, I can pass it up once, twice. I can do it as many times as I want, so I could add 360 to that again. 4, 840. And I can keep going up as many times as I want. And it's describing the same angle. I'm just passing it one time around. I'm going all the way around. Yes? Questions on this here? Are we good with this here so far? So really we're describing this angle here, and we can go around 180, 360, and then go that additional amount to get to that same point.
So we're basically studying the distance between.
Yeah, so it's really saying that 120 and 480 and 840, if I were to chart these angles, end up putting me in the same exact place. It's almost if you've ever cranked a wheel around. So if I did to wherever it would be at 120 on that wheel. If I went all the way around again to 480, I'd be in the same position as I did for 120. I could do it all the way around to 840. So it's just we're hitting the same spot. I'm just going around the circle one full time to get there. Does that make sense? Or kind of make more sense? Now, we don't have to go that direction. I could also go, and again, since I'm going clockwise, this would be negative. So really what I'm looking at is 120 minus, because this direction I went how far? 120 degrees. This direction I'm going the negative. I'm going the opposite direction. And both of these, again, if it makes a full circle, it is 3. So negative 240 and 120 go to the same spot. They're the same angle. They're coterminal angles. Yeah, so it's not actually talking about a distance. It's talking about these angles. It's just talking about purely about the angles. Does that make sense? And really, all of this here, our coterminal angles, can really be described in degrees as, so coterminal angles is our theta, whatever our angle is, plus 360 in. Because as we saw already, I can do pretty much, given the example of if our angle is 120, well, 360 times 0 would just be 120, our initial angle. Well, I can do once, I can go around the circle once. Well, that's just 120 plus 360, which gave us our 480. Our 2 gave us our 840. Now the question is, can we do the other direction? Well, yes. I do a negative. Because I went negative one direction, the opposite direction, which would give us a negative 240. Questions on this here? We good with this here? But that's it. That's it for coterminal angles. And the assignment's going to ask you for one positive, one negative coterminal angle, given that the angle is, let's just say, 120. I'm done. You really add 360 to it and subtract 360 from it. Questions on this here? Okay. Let's do one where we're given that the angle is 720 degrees. I need one positive coterminal angle and I need one negative. So plus 360, yes? So that would be, I can say 1080, yes? Well, then we can also subtract 360, yes? And then we'd be done. What's 720 minus 360? So I have my one positive and one negative angle. No, I have what? Two positive angles, yes?
It has to be bigger. So 0.
Now do I have one positive, one negative? 0 is not negative.
So you have to do a negative 360.
So you'd have to go 3 times 1.
Yep, I'd have to keep going backwards. So some of them might be so big that we have to do it a few times, but that's it. Questions on this here? We good with this here? And that's kind of our examples. Radian measure. So this is dealing with pi. We're talking about the angle is the S, the arc length over the radius. So how far the arc is, the length of the arc over the circle's radius. So we get this here, and this is really talking about 2 pi r. 2 pi r is the distance, the circumference of a circle, or pi d, pi times the diameter, 2 pi r, is the circumference of the circle. This really talks about our radians, this here. We contain the following, or these here, pi over 3, pi over 4, pi over 6, which you believe is 30, 45, 60, 90, 180, and 360 degrees. Now, we can go through this, and there's this here, and we'll get more into this, especially when we talk about unit circles and how these work out. So 0 and pi over 2 is in the quadrant 1. Quadrant 2, quadrant 3, quadrant 4 are set up like this here. And I will give you a unit circle. We will fill out a unit circle that's going to have these on there, and you can use these on the test. Okay? Now, here, so on and so forth. Finding coterminal angles for this here. Theta plus, not right, wrong one, 2 pi n. Because it works out 2 pi is the entire circle. So the entire circle is 2 pi. So for degrees, for our coterminal angles, we did theta plus 360n, the whole circle. For radians, it'll be theta plus 2 pi n. Same exact thing. So if I subtract 2 pi, we can type this into the 30xs, and let's see what we get. So this doesn't matter. Minus 2 pi. Pi over 6, yes? So one coterminal angle for this here would be pi over 6. So if I want a negative one, do it again. See what we get. Negative 11 pi over 6. So pi over 6 minus 2 pi. Would that give you negative 11 pi over 6? Yep. So we can do the same thing with pi with these coterminal angles. So I just did it again. So we can almost do the same thing with our radians. We can add 2 pi and subtract 2 pi to find the coterminal angles. And that's it. Questions on this here? Okay. Mm-hmm. Well, we can add it, quote unquote, add it, but what we're really doing is I can say 13. Because it could be the same as plus, and then setting our n as negative 1. Now, the reason they're talking about subtracting it to contain a coterminal angle, since I know this is greater than 2 pi, because 2 pi would be the same as 12/6. So it's bigger than 2 pi. So I know if I subtract 2 pi, I'll still get a positive angle. We could have also added 2 pi to get another positive angle. Either one would work. Yeah. So we could talk about theta being 7 pi over 4. I want to find another positive and negative coterminal angle. So I could start off, if I want to, by subtracting 2 pi to see if I get a positive or negative. And this would be negative pi over 4. So that gives me my one negative, yes? So I still need the positive, so I can do what? Well, if I add it to negative pi over 4, I'll get back to 7 pi over 4. So I'll start with it and add 2 pi. 15 pi over 4. And that's it. So with degrees, we're really just adding and subtracting 360 to find the coterminal angles. And for radians, we're adding and subtracting 2 pi. Questions on this here? We good with this here? Okay. Now for two positive angles, alpha and beta, two positive angles, alpha and beta, are complementary, complements of each other when their sum is pi over 2. Well, we talked about this in geometry. Complementary angles add up to be 90. Supplementary add up to be,
180.
so pi over 2 is 90 degrees and pi is 180. So if we talk about two angles, so if I have an angle that is pi over 4, and I want to find its complementary angle and supplementary angle, well, complementary means that they add together to be what? 90, or pi over 2. So to find it with pi over 4, I would take pi over 2 and subtract from it pi over 4. And pi over 2 minus pi over 4 would be, let's see, is 1/2 minus 1/4. So the other one is pi. Supplementary is pi. And so to find it, I can do pi minus pi over 4. And I think we should get 3 pi over 4, yes? Because we could change this to now, any questions on this here? So for really, if we're talking about just in general is theta for any angle, for complementary, we're doing pi over 2 minus theta. And for supplementary, doing pi minus theta, yes? And these here, for them to work, have to be greater than 0. Because if they're negative, it means the angle that we're starting with is either greater than pi over 2 or greater than pi. If it's bigger than both of these, well, it just doesn't work because it means the angle would be negative. That means its complement angle would be a negative angle. We don't deal with negatives. Questions on this here? You good with this here? If you have questions, you'll let me know. Degree measure. So we can talk about this now. A degree measure is equivalent to a rotation of 360th of a rotation. Because each one, they all add up to be 360. We go all the way around. 2 pi is the same thing. So 1 radian is equal, or 1 degree is equal to pi over 180 radians. 1 radian is equal to 180 over pi. So if I want to convert from one to the other, if I want to convert into radians, I do my degree measure times pi over 180. If I wanted to convert to degrees, I multiply the radians by 180 over pi. So for instance, if we have that the angle is 2 radians, so to find the degrees, well, I'm going to take that radian measure and multiply it by 180 over pi. You can type that in, because most of these here, some of these here, if it says round to 3 decimal places, you're just going to write it as a decimal. I have a feeling the TI-30XS said 360 over pi, or approximately what? degrees. And that's it. Questions on this here? Let's say radians. So let's say the degree for our angle is 65 degrees. So if I want to convert it to radians, we're going to take 65 and multiply it by pi over 180. And you can multiply or type this into the calculator. It would be, if it was 39 on bottom, then it'd be 1/3. But that's it. Questions on this here? So I think converting from degrees to radians and radians is degrees, we're good? Because those aren't bad. Because if I wanted to convert 135 to radians, well, I would do 135 times pi over 180. 5 goes into both of these, and that would be 227 over 36, which is 3 pi over 4. And we can do the same thing with 540. And that's it. Questions on that there? We good with that there? Now this is the last thing we'll talk about with arc length. For a circle of radius r at a central angle theta, interpret the arc length given s by this here. S is equal to r times theta. So if I know the radius and the arc measure, we'll multiply them together. Now, for these here, we need the arc in radians. We need the arc measure in radians, not degrees. So they told us it's 240 degrees. I can convert this from degrees to radians by multiplying it by pi over. And if we type this in, I'm just checking something. Okay, good. So we get 4 pi over 3. That is the measure of this here, 4 pi over 3. And if I want to know the arc length s, well, s is equal to theta times r. Well, our theta value is 4 pi over 3, and our radius is, well, if we multiply that, we'd get 16 pi over 3. Or approximately, that's not going to be 5, it's going to be bigger.
755. Right?
So that would be the length of that arc. And that's all we have to do for this here. Questions on this here? So we'd have to convert 240 to a decimal, then we'd plug it in here and find our answer. Now we're not going to talk about linear speed or angular speed, because linear speed is just talking about as the circle progresses, what is the speed of this here? As it's going out, what is its linear speed? Angular speed is the speed as it rotates. So if we talk about revolutions per minute, or revolutions per second, or revolutions per hour, we're talking about its angular speed. How is it rotating? And for the circle this here, we can find its central angle, but I'm not too worried about that, and it's not going to be a part of this assignment. But that's pretty much it.